Hello, everybody. We are starting our next section, which is going to be going over tangents. And this section actually pulls a lot of those triangle relationships as well as Pythagorean theorem. So we're going to be jumping a little bit back to triangles and applying it to circles. So let's dive in. What is a tangent? A little bit of reminder. A tangent line intersects a circle at one point, and that point is called the point of tangency. A line is a tangent to a circle if and only if it is perpendicular to a radius that is drawn to the point of tangency. So that kind of hints at where we're going to be using Pythagorean theorem, because you're going to have that right angle to create those right angles. So you'll have your radius here. Your radius connected to your tangent will create a right angle. Our first type of problem will be trying to determine, okay, do we actually have a tangent? So, looking at this first problem, I have all of my sides of my triangles. I need to identify, okay, where is my tangent? My tangent's going to be AB because it connects at point A and extends off the circle to B. How do I determine if it's a tangent? Well, if I have a tangent, this angle right here, angle PAB or BAP, is going to be 90 degrees. How do I ensure that that's a 90-degree angle? Well, we can use the Pythagorean theorem to test that out. So, if this is a right angle, my sides, 8 squared plus 15 squared should equal 17 squared. If that's not true, then I do not have a tangent because that's not a 90-degree angle. So 8 squared is 64. 15 squared, I don't know that off the top of my head, is 225. If I add those together, that gives me 289. Okay, I gotta test what 17 squared is. 17 squared equals 289. Okay, so that is true. Therefore, AB is a tangent. All right, let's try it on this problem. My tangent should be AB. So that means at this angle should be 90 degrees. I'm going to take my legs, add them together, and set it equal to my hypotenuse squared. So 11 squared plus 14 squared is equal to... Oh, wait a second. Okay, we don't have the measure of that whole side. How do I find the measure of that whole side? Well, look here. What is this segment right here? That's a radius. Isn't this a radius over here too? So this should be 11. Therefore, this whole segment, 11 plus 5, that gives me 16. So my hypotenuse is 16 squared. 11 squared is 121. I do not know 14 squared off the top of my head. 14 squared is 196 plus 121 gives me 317. All right, what is 16 squared? It's 256. Okay, that's not equal. Therefore, AB is not a tangent. Okay, so those are the two type examples you'll see as far as determining if you have a tangent or not. Okay, so let's do some more calculations. Here, example 2. If JK is a tangent, find X. All right, X is going to be, let's change it up. Change a different color. X is right there. Okay, and one thing I do notice is X is a radius. Okay, therefore, it will be congruent to this other segment, LM. So LM and LJ are going to be congruent because they're both radii. Okay. All right, how do I solve for X? Well, I can use Pythagorean theorem. Okay, I'm just going to make this whole thing y just so we don't have any confusion. So y squared plus 7 squared is equal to 25 squared. Y squared plus 49 equal to, what's 25 squared? 625. So 625 minus 49 is equal to, y squared is equal to 576. Take the square root, giving me an answer of y is equal to 24. All right, so if y is equal to 24, that's the diameter. To get my radius, I'm going to divide by 2. So x is equal to 12. There we have it. All right, there's two other relationships in concern to tangent lines. If two segments from the same external point are tangent to the circle, then they are congruent. So here in this example, AB is going to be congruent to BC. Another relationship is if you have a polygon that is circumscribed around a circle, then all sides are tangents. So you could think of D, E, and F as points. So all of these little segments pulling off are tangents. So let's look at that in some examples. So right here, example 3, find X. Assume that the segments appear to be tangents or tangent. All right, I have both of those tangents connecting at an external point. Therefore, they're going to be congruent. So I can take 5x plus 23 equal to 8x minus 19. I like to keep my x positive, so I'm going to subtract 5x. And I'm going to add my 19 over to isolate my x. 2, carry my 1, 42 is equal to 3x. X is equal to, why can I not do that off the top of my head? 14. There we go. Winner, winner, chicken dinner. Okay. One more problem. All right, my circle here is circumscribed inside the triangle. And I am wanting to find the perimeter of DEF. Well, we could take the relationship we used in the past example and apply it here, because we know when we have a circle circumscribed in a polygon, those tangents, or all the segments around it, are tangent. So, and they all connect at external points. Therefore, corresponding tangents that meet at the same point are congruent. So if this measures 16, we have 16 here, 9.5 here, and 11 here. Okay. And if I add all that up, that will give me my perimeter. So 11 plus 11 plus 16 plus 16 plus 9.5 plus 9.5 gives me a final answer of 73. Okay. And that's it. So there's not a lot to tangents. It's really just identifying and understanding those tangent properties and using the triangle calculations that we have done before. Okay, if you have any questions, let me know, guys.